So let me explain number 6 from exercise 22.1. Okay. Okay, and then let's see if you got the correct answer. Okay. So for number 6, the height h meters of a stone t seconds after it has been thrown vertically upwards from the ground level is given by h is equal to 24t minus 3t squared. So basically, class, from the first sentence right away, we know that a stone is thrown upwards, right? So it makes this projectile right here. And the displacement or the height is given uh, with this, I mean, by this equation right here. So height is also displacement. It's also the distance, okay? So the first question is, let's find its velocity after 3 seconds. So for letter A, again, h is displacement because it left your hand, or maybe it left the ground and it went up in the air. Okay, so it's displacement. So the question here is when t is equal to 3 seconds, right? So the problem here is that we're not given the velocity function, right? So we need to derive that out of the uh, displacement function right here. So doing so, dh over dt, or the derivative of h with respect to t, is equal to 24 minus 60. Okay, so from here became this one. Okay, so therefore this is now the velocity function. And then plugging in 3 here for 3 seconds. So the velocity after 3 seconds is 6 meters per second. Okay, so that's your answer. 6 meters per second. Now let's go to letter B. So find the maximum height reached by the stone. Okay, class. So again, I told you guys a while ago that when you throw something and it reaches its maximum height, that means after that particular height or its maximum height, the direction of the stone is now downwards. Okay, that means that reaching its maximum height is also the same as having it instantaneously at rest. Okay, because it turned, okay, it turned around on its maximum height. So for that maximum height, that's equal to velocity equals 0. Okay, so using the velocity function here, so velocity is now 0. So what do we need to find here? Okay, so we need to find the height. So to find the height, we need to also find the time first, or the amount of time it took the stone to reach this height. How long? Okay, so that's why it will come out from our velocity function, because we know that the velocity here is 0. So from there, solving for t is 4 seconds. Okay, so it took the stone 4 seconds to reach its maximum height. So this is 4 seconds. Okay, and with that, using the height function or the displacement function, so just plug in 4 here for 4 seconds, and then the maximum height is 48 meters. Okay, 48 meters. Okay, 48 meters. And then for letter C, we need to find the time of flight. Okay, so the time of flight again is from the moment it took off the ground until it went back to the ground itself. Okay, so how long did it take? So basically, class, the question here is the time. Okay, again, time of flight is from the throw until it reaches the ground. So that means that if it reaches the ground here, that means that the height of that is now 0, right? So using the displacement function or the height function in this case, we make h equal to 0 because the stone is already on the ground. Okay, so 0 is equal to 3t times 8 minus t. So I just factored out 3t from this expression. So doing so, 3t is equal to 0 and 8 minus t is equal to 0. So I have two answers here, 0 and 8. Of course, we reject 0 because 0 is where it started, right? And then, so okay, it took the stone 8 seconds, okay, until it went back to the ground. So that's your answer for letter C, 8 seconds. So that's the time of flight of the stone, okay. So class, do you have any question about number 6? No question? Okay. Okay, so that's it. There's no question for number 6. Okay. So let's continue with the examples. Okay, so uh, okay. So let's continue with number 6. Okay. Number 6 is a bit it's a long question. Okay. It's a long question. Okay. So but let's have this now. So I only have two examples. So a particle moves along the x-axis. Okay. It passes the origin with a velocity of 8 meter per second, and its acceleration is a, yeah, this one, per second squared. After passing O, is given by a is equal to 3 minus t. Okay, so this is the acceleration function, right? So we need to calculate first the velocity of the particle when t is equal to 2. So for letter A, we already have the time, so that's all what we need. But then, we don't have the velocity function, right? We're just given the acceleration function. So how do we go back to velocity from acceleration function? Okay, so this is the S, V, and A. So if we go back here, what do? We integrate them, right? So we need to find the antiderivative of A, this one. So to get V, we need to get the derivative of 3 minus t with respect to t. So doing so, 3 becomes 3t, and then t here becomes t squared over 2 plus c. Okay, class, this one. What is c here? Okay, so here, when time is 0, because it's still on the origin, okay, velocity is 8, right? From here, from the sentence itself. Because it passes the origin with a velocity of 8. So if it's on the origin, time is 0, and then but then the velocity is already 8 meter per second. So therefore, c is equal to 8. Okay, so you just plug in 0 and 0 here, and then here is 8. So c is equal to 8. All right. So that's why you got 8 right here. So now this is the velocity function. Okay. And to find for the answer, so you just plug in this function, and then you will get 12 meter per second. And that's your velocity in 2 seconds, okay? The velocity of the particle in 2 seconds. Okay, now let's go to letter B. Now, letter B, it's asking for the maximum velocity of the particle. Okay, maximum velocity of the particle. Okay, so again, it has something to do with the maximum point and minimum point. So if it's maximum point, that means our velocity here is equal to 0. Okay, or the derivative of the velocity is equal to 0. Okay. Okay, so to find the maximum velocity, take note, class, that again the derivative of the velocity is equal to 0, and then we know that the derivative of v is equal to the acceleration, right? So if you still remember the S, V, and A, if you derive V, you will get acceleration. So therefore, as acceleration is equal to 0 as well. Okay, so using the acceleration function given, A is now 0 and then 3 minus t. So therefore, t is 3 seconds. Okay, 3 seconds. So the short explanation here, class, is that, okay, in 3 seconds, we will find our maximum velocity. Okay, so how do we find for the maximum velocity? Okay, okay, class. So this right here. So I just proved that if your answer for the second derivative of a function here, in this case, the acceleration function is a negative. That means that uh, yeah, that this has something to do with the maximum velocity. Okay, so anyway, from here, let's jump right here. Okay, so using the velocity function, because that's the question right there. Okay, so the maximum velocity is equal to 3t minus t squared over 2 plus 8. Okay, so if you remember, this came from letter A from right here. Okay, so let's answer this now. Okay, so plugging in 3 seconds here, your maximum velocity is 12.5 meter per second. Okay, so that means that you will reach maximum velocity in 3 seconds. Okay, so that's it. And this is the speed of your movement. So that's letter B. And then let's have letter C. So C is how do we find the displacement of the particle from O when it is at rest? Okay. Okay. The problem here, class, is we are asked for the displacement function. Okay. Okay. And then from O when it is at rest. So at rest means time is zero, where velocity is equal to zero, right? So anyway, I'll find first the displacement function using the velocity function. So how do I go back again? So this is S, V, A. So from velocity to displacement, you need to integrate velocity, right? So doing so, I'll find the antiderivative of this expression right here. Okay, so I'll get 3t squared minus t cubed over 6 plus 8t plus c. So what is c here? C. Okay, so we know that for letter C, the particle is at rest. It's not moving. So if it's not moving, it's not consuming time. So if T is 0, V is also 0 because it's at rest. So therefore, C is equal to 0. So this 0, 0, 0, and then S is also 0. Everything here is C is equal to 0, right? Okay, so this is your um, displacement function. All right. So again, if the particle is at rest, that means that its velocity is equal to 0, right? So using the velocity function, this one, make it equal to 0. Okay. And then what do you do next? Okay. Obviously, you need to solve for t. Okay. Okay. Solving for t, you can factorize this. Okay. Which is this method that I did, or maybe if you want, you can just use the quadratic formula. If you remember the formula, it's also fine. Okay, the quadratic formula will be given during the test. Okay, only that. It's in the first page as usual. Okay, anyway. Okay, so here I did factorization here, but if you want quadratic formula, it's fine. Okay, so what I did here is to remove 2, and then so basically to remove 2, I need to multiply this by 2, so it cancels out. But 2 times 3t is 60, and then 2t times 8 is 16. Okay, and then no more denominator. Okay, so this one, factorize this. Your answer is t minus 8 and t plus 2 equals 0. So solving for t, you got 8n negative 2. But then, of course, time is always equal or greater than 0, or only positive, not negative. So we reject this and we accept t is equal to 8 seconds. Okay, well, answering the question, what's the displacement of the particle when it's at rest? Okay, so we have our time. So to get the displacement, so using the displacement function, we plug in 8 in place of this. Okay, so therefore the displacement is equal to 74.7 or 75 in that case. So that's the displacement of the particle when it is at rest. Okay, so it's 75 meters away from the origin. Okay, and then lastly, letter D. So letter D is the average speed during the first 12 seconds. Okay, during the first 12 seconds. Okay, okay, wait, let me change my illustration here a little bit. Okay, I'll use a straight line instead. Okay, okay, okay. Anyway, in here, the question is, how do you find the average speed, right, during the first 12 seconds? So first, you need to find the displacement after 12 seconds, and that is 24 meters. Okay, so 24 meters. Okay, let me write it here. Okay, okay, so it's illustrated by this line over here. Okay, as you can see, class, if you have observed, okay, after 8 seconds, the distance is 75 meters, right? Okay, so the distance is 75. But then, as the time progresses, we went back closer to the origin. It's now only 24 meters, right? Because from question number or letter C, the particle here is instantaneously at rest. Again, if whenever you see that phrase, that means it turns around in that uh, particular distance. Okay, so after, let's say, 9, 10, 11, 12 seconds. So after 12 seconds, it's just 24 meters away from the origin. Okay, so this is 24 meters because it's the displacement. Okay, so how do you find the average speed? So the average speed after 24 seconds is, so basically this one right here. So this is 74.7 meters. Okay, plus, what's this? Okay, so you can get this when you subtract 74.7 and 24. So that gives you 50.7, right? Let me erase this. So, oops. So that is 50.7. Okay. So again, the average speed. Again, what's the formula for average speed? Total distance over total time taken. Okay. So again, the distance from here, from origin to, okay, to this particle here, as it turns around, is again 74.7 meters. And then after 20, after 8 seconds, it turned around until here. After 12 seconds, it reaches this distance. from the origin. So it's 24. So this one plus this one. That's your total distance. Okay, so 74.7 plus 50.7 divided by 12 because over 12 seconds. And then that's it. That's your answer. It's 10.4 meter per second. Okay, let me just finish this. Okay, number 8. A particle P moves in a straight line so that its displacement from a fixed point O seconds after passing through point A on the line is given by this function right here. Now let's calculate the speed of P when T is equal to 2. Okay, so we're given the displacement function. So in order for us to solve for speed, we need to get the velocity function. So doing so, we need to get the derivative of this. So this is our answer for that. So the derivative of s is equal to 3t squared minus 60 minus 9. So this is our velocity function now. Okay, so to get the speed is the same as getting the velocity. Okay, so when t is equal to 2 seconds, so just plug in 2 in place of the function here. So velocity is negative 9 meter per second. So therefore, the speed is 9 meter per second. So that's your answer for letter A. Again, speed is an absolute value of velocity. Okay. Now let's go with letter B. So letter B, let's calculate the acceleration of P when t is equal to 4. Okay. So basically, class, we don't have the acceleration function yet. So we need to get that by deriving the velocity function, and that gives us our acceleration function. So doing so, I will get 60 minus 6. It came from here. So getting the derivative of this, I'll get 60 minus 6. So this is our acceleration function. So after 4 seconds, the acceleration is simply 18 meter per square second. Okay, so that's letter B. So that's the acceleration of the particle when t is equal to 4 seconds. Okay, and then let's jump right away to letter C. So let's find the distance of P from A when it is instantaneously at rest. Okay, so instantaneously at rest means vector is equal to 0. So using the vector function, V now becomes 0. And then basically you need to solve for the value of T, or we need to find the time. Okay, so finding for T, so I did factorization here, but then you can still use the quadratic formula. It's fine. Okay, so factorization here, or factoring the given function. So I will have t is equal to 3 or t is equal to negative 1. So again, t or time is equal or greater than 0. So time cannot be negative. So we reject this. So the correct answer here is 3 seconds. Okay. So the particle turn around at the 3-second mark. Okay. So the question here, class, for letter C is we need to find the distance, right? So finding the distance is the same as finding for its displacement. So using the displacement function, just plug in 3 seconds in this function, and then you will get 3 meters. But 3 meters is not the answer right here. So for you guys to see this clearer, so I have here this illustration, okay? So Uh, right away from the start class, we're given this displacement, right? So this is the origin. And now at 0 seconds, if time is 0 second, okay, we can right away tell that the displacement is at 30 meters. Okay, because if this becomes 0, 0, 0, s is equal to 30. So it's right here. Okay, so time is 0. displacement is 30 meters. Okay, so even before this particle moved, it's already 30 meters away from the origin. Okay, it's already 30 meters. Okay, so this one, it didn't start from the origin. It started at this point here, which is point P. Okay, now for letter C, it's asking the distance of P from A. Now, where did we get A? Just right now, here. Okay, so for point A, we know that uh, at the 3-second mark, uh, point A is just 3 meters away from the origin. So, this one. Okay, so it looks like this. So, it started here, going here, and it will turn like that because again, in point A, the vector is instantaneously at rest. So V is also 0 here. Again, if it's instantaneously at rest, that means from here it will turn around on point A. Okay, so from 30 to 3, so what is the distance there? So basically, class, so the distance there is just 27 meters. So that's your final answer, class. So for letter C, the distance between, I mean, from, uh, sorry, for P from A is 27 meters, or you can write that as 27 units as well. Okay, so that's the distance of the two. Okay, so with that, let's answer letter D. So what is the average speed over the first 4 seconds? So given the time is 4 seconds, so uh, to get the average speed, I need the total distance, right? So here, I'll take the distance after 4 seconds. Okay, so after 4 seconds, the distance of the particle from the origin is 10 meters. 10 meters. So it's here. So this, the particle now is over here, which is uh, 10 meters away from the origin. So again, the particle started from P going to A, and then from A it turned around, and then it ended here, okay, at the 4 second mark. So this is 4 seconds. Okay, so what is the average speed? So the total distance covered is this first, okay. So this one is 27 meters, and then so after 3 seconds it turned around, right? So there's a distance here up to here. So what is the coverage here? Okay, so that is 7 meters here. And then divided by, okay, so the time taken, it's 4 seconds. So your answer here, class, is 8.5 meter per second. So that's the average speed of the particle after, I mean, on the first 4 seconds. Okay, so let me use Desmos in explaining this one. Okay, so again, class, this one, okay, you can use Desmos. Again, uh, okay, let me just take a quick screenshot of this. Okay, this one, class. Okay. All right, so again, this is the function, right? So this is the same as, okay, it's 30 meters away from the origin, right? So it started here, and then the particle went here, and then okay, on the 3 second mark, okay, this is 3 seconds, okay, uh, the particle is just 3 meters away. Sorry for that. Okay, so this is just 3 meters away from the origin. Okay, class, whenever you solve for displacement, the answer there is always measured from the origin to that certain place. Okay, so this is where the particle now, which is 3 meters away. So this is 3 seconds as well. Okay, and then on the 4 second mark, okay, So this is the 4-second mark right here. So time is 4 seconds. So the displacement is already 10 meters. So this is what? So that means that this is 10 meters away from the origin. Okay, so that's why this is your total distance. Okay, over 4 seconds. So that's how it looks like in a Cartesian plane. Okay, so that's letter D from number 8.